Chapter 4, Friction. So if you have friction between two surfaces, we will call the surface called rough surface. If there are no friction between the surface, we will call it smooth surface. So if you refer to the notes, you will see the equation F equal to mu R. So the mu will be equal to the coefficient of friction, and the R is the normal contact force. The mu will be depends on the type of friction or the roughness of the friction of the surface. So when you have two surfaces, when you have an object sit on the surface, okay, you will have a normal contact force R here, and mg will be opposite direction, and you have if you want to move this block in this direction, okay, the frictional force will be at the opposite direction. So if you increase this force, the frictional force will be increased until certain points. The block will going to move. So when the block going to move, or the block already started to move, the friction we will call limiting friction. So the limiting friction we can consider as the largest frictional force that act on the body, between the body and the surface. So if we refer to back to the formula there, F equal to mu R, and F always smaller or equal to mu R, right? So your maximum value of frictional force will be mu R. So the mu R can be add on a horizontal surface or make on the inclined surface. This inclined surface, you have to consider the angle that add on the items. So at the another terms that we will use is total contact force. Total contact force we can define as C equal to square root of R square plus F square. So the total contact force depends on the situation. If this is in the horizontal surface, the total contact force will also make a certain degree to the horizontal, and if it at the inclined surface, the total contact force will have a different angle to the surface. So we can find the angle between the total contact force and the surface by using inverse tangent F over R. So this is the way to find the total contact force. So if we refer to example 1, a box that rests on a horizontal surface, and you have a normal contact force R, and you have a pulling force 8 Newton. And if you have a pulling force 8 Newton, on the opposite way you will have a frictional force F, right? So if the item will sit on a rest situation, so the horizontal force they are equilibrium. So you can say that R will be equal to 5G for the vertical force, okay, and F equal to 8 Newton. Okay, if you want to find the total contact force for example 1, C will be equal to 8 square plus 50 square, right? So you should able to find that C is equal to 50.6 Newton. Okay, hope you can get that.